Hi folks, I want to try doing something a little different tonight. I've never made a video about one of the sewing machines in my collection. And I've got about a dozen machines, some of which are fascinating and innovative and space age, and some of which are very pedestrian and workhorses and are dull. This is an extremely average machine. But even average machines can be interesting, and I'll tell you what I like about this one. And I'm going to take the box off it, take the cover off it. This is a very standard type of box that was put on machines from the mid-50s to the late 60s. I'm going to open this up, and we'll take a closer look at it in a minute, but I'll just open it up and just show you what it is and why it's both average and interesting at the same time. In about 1968, if you walked into any house, this is probably the type of machine you would have seen. It's labeled Kenmore, which was a Sears brand. Kenmore was, in Canada, was made for Simpson Sears, and this is a Canadian production model. But these weren't made in Canada. This particular one was made in Japan, as a great many machines were. After World War II, they were looking for things for the Japanese to do. They had a lot of machinists and tool makers who had been making nasty things during the war, and they wanted to give them something productive to make. So the Japanese were given access to patents, and a lot of patents had expired. And the Japanese were encouraged to build a sewing machine industry, which they did, and they made some superb machines. And this type of machine is what was called a badged machine, because you had many companies make them, and they would put a name on it for whoever was selling it, for the retailer, for Kenmore, for Marshall Fields, Eaton's the Bay, you know, whoever, Atlas, whoever wanted to sell a machine, they would order these from a Japanese factory. Now, what makes this particularly interesting, I think, even though it's a very average machine, if you were to go through all the machines in my collection, if you were to pick them up, something stands out about this one. Now what stands out about this one, well, the modern machines, you buy a modern machine which is mostly plastic, they'll weigh about 12 pounds. By the mid-60s, most manufacturers, the American manufacturers, Singer certainly, and the European manufacturers, were using cast aluminum in their machines. The cast aluminum machines weighed 17 to 21 pounds. This thing weighs a colossal 44 pounds. And even though it's considered portable, it most certainly is not. It's hard to lift this from the floor to the table. 44 pounds is an enormous amount of weight for a machine. It's cast iron. It's not aluminum, it is cast iron. Another thing that's particularly interesting about this machine is the manufacturer, and it was made by Toyota. And you're probably thinking, oh, that's interesting, it's the same name as the people who make the cars. Well, in fact, it's the same company who made the cars. This is made by the company, Toyota, that makes Toyota cars. Let's just take a little closer look at it. Now, this machine was probably made in about 1967. And I say that because it's got some features that you didn't find on the very early Japanese machines. You would get machines in this type of case and this general style in the late 1950s. But this has got some extra features on it. Particularly noteworthy is the fact that it's a zigzag machine, and it also has a special function up here for the automatic buttonholer and blind stitcher. And that's not something that you would have found on the very early machines. So this is likely circa, again, 1967. It's got these nice hinged spool pins, which I like. They won't interfere with the case, and you can just fold them down. This push button thing selects your buttonhole and blind stitch. I better make sure I go all the way through that, or else I'll be in the wrong position next time I go to use it. This, and again, as a zigzag machine, that was not something you found in the early machines. And this controls the width of the zigzag. This controls the length of the stitch. This is the reverse. This raises and lowers the feed dogs. Another thing of note, which you didn't find on a lot of Japanese machines, is down here. This would be referred to as a front-facing machine. Let me just dip the camera a little bit here, because the bobbin goes in from the front. This is considered the side, and a lot of these machines, you would see this plate pointing this way. On the front-facing machines, you could use a twin needle, which is why it's got two spool pins up there. And so, again, there are features on this that lead me to believe that it is a later machine. I want to turn it around so we can take a look at the motor. And motors usually aren't much of a big deal. They were pretty common, pretty standard. They weren't generally, you know, particularly special. But this one is really nice. This one is well, it looks like it's chrome plated. I've seen that's got better chrome on it than most old cars do. And another thing is the motor is made in Canada. Again, this was kind of standard practice, is that the machine head, as they called it, which is the basic sewing machine, would be made in Japan. It would be shipped. These were shipped all over the world, and generally a motor that was appropriate for local current and voltage was supplied in the country where they were destined to operate. And this one is made by, of all companies, Shoe Machine Parts Limited, which sounds a little bizarre, but Shoe Machine Parts Limited of Toronto. But they were a major manufacturer. You see a lot of these machines from this era. This is who made the motors. And this is a 1 amp motor, which is actually rather large for the size. A lot of Singers from this era were 0.5 or 0.7 amps. So that's actually a fairly sizable motor. This is what is called a short shank machine, which basically describes the type of presser feet and accessories that it will take. And short shank machines are the most common machines in the world, so it's still very easy to buy parts for this. You can go on Amazon and you can find 10,000 listings for accessories for this. Here's the, and again, there's the front-facing bobbin in there, and this uses what is called a class 15 bobbin. Again, the most common bobbin in the world. Holds lots of thread. In fact, this one has actually got a threaded bobbin in it right now. Again, you can buy those bobbins anywhere. Excellent. It's an excellent design. Excellent. Again, this type of bobbin holds a great deal of thread, so it's common. It's easy to get, very high quality. And it's a machine that's still very easy to use even today. Now here's one of the most important things about this machine. And it's something I should have mentioned earlier. And this is why people like me like old machines and why we buy them. Is this machine is entirely steel geared. There's no plastic in this. Most machines today, well, pretty much all domestic machines today have plastic gears in them. Europeans actually started using plastic gears in the 1950s. Singer was eventually forced to start using plastic gears in the 1960s. Now, the thing about plastic gears is they are quiet, they are clean, and they are easy to maintain because they don't require any oil. But let's be honest, the main reason people use plastic gears, or manufacturers use plastic gears, is because they're cheap. They're injection molded, they're very cheap to make. And I don't have to tell you what happens. Well, I don't have to tell you what the difference is between a plastic gear and a steel gear. A plastic gear is probably going to work fine for several years. A machine that has steel gears can easily last 100 years. I've got a machine from the 1930s, which is just fine. I've got several from the 1950s, steel-geared machines from the 1950s. They're fine. Plastic gears will inevitably fail. It just happens. Again, this machine is probably 53 years old. It should last another 53 years if it's kept lubricated, and that's all it requires. And that's the main draw for these older machines, is that the steel gears, the steel running gear, not just the gears, but all the shafts, the cams, will essentially last forever as long as the machine is lubricated. Well, that's just about it. Two comments I'll make before I go. One of the things you got with 44 pounds is a machine that basically will not vibrate. Okay, if you've got a machine that weighs, like a modern machine, weighs 12 pounds, and you've got things spinning around in there, it's going to dance across the table. Even the ones from the 60s and early 70s that weighed 17, 21 pounds, they can shake a bit. This is not going to go anywhere. And final thing I want to say is, you know, why would people collect these? Why would people buy these? Because, you know, so many technologies go obsolete, like film cameras. You know, I've invested a lot of money in film cameras, and they're basically all doorstops now. The thing about sewing machines is, no matter what kind of computerized gizmos you put on them, and modern machines are computerized. It's very handy. They can select your stitches and control the speed and do all sorts of interesting things. But at the end of it, sewing is still a mechanical process. It requires a needle to go through fabric and a spinning hook to grab that thread and make a stitch. So it's still a mechanical process, no matter what kind of electronics are on it. It's a mechanical process. So a machine that's 100 years old is still going to work. So there we have the Sears Kenmore, average machine from the late 60s.